All right, so I'm Matthew Shackstead. I'm CEO of ParallelWorks and co-founder. We're going to talk about our technology that we've been building for about 10 years. It's 10 years in June. We've been making this thing really focused on enabling hybrid multi-cloud computing. Yes.
Can you hold up for just a second?
Sure.
Do we have this for AV? Are we recording this? Are we back in recording mode?
I see a thumbs up.
Okay, excellent.
Okay, so that's what we're going to talk about. Pretty short agenda here, but I'll give you an overview of the company and our technology. I actually flipped the order around. I'm going to first talk about, I've heard that there's some familiarity with things like open on-demand. I'm actually going to talk about that first and how we, where we sit relative to that. Talk about how we enable organizations to adopt multi-cloud programs and what that means in our perspective, and then just run through a whole bunch of case studies. If there's more time, I got live demos I can bring up. We can, kind of take this however you want to do that. So a little bit of overview on the company. We sit as and we'll talk about this, we're seeing the world, and really from 10 years ago too, the world of interfacing to different computing systems has changed a lot, as I'm sure everybody has seen. And we started in the world of creating software to run workflows on large on-prem supercomputing systems. I'll talk about where we came from. And that kind of moved into cloud environments and specifically hyperscale clouds. We're doing a lot more work with GPU as a service providers. People are buying GPU clusters and putting them on in their data centers or colos, and they're running things like Kubernetes on it. We're doing deployments with virtualized infrastructure and VMware OpenStack. So all these things have different interfaces, and within an organization that has a lot of computing going on, which is a lot of the organizations we work with, it's very rarely just one of these interfaces. And so we're kind of in this world where we're trying to collapse that down, and we'll talk a little bit more. So where did we come from? We actually spun out of Argonne in 2015, my partner and I. He was the PI of a project called SwiftLang, if anybody's heard of that. It was a programming language to help run large-scale open source workflows on supercomputing systems. That turned into the Parcel project in this day and age. So we actually spun out of that group. And I was working in engineering companies, and we said, hey, let's try to bring this type of technology to industry. We took that technology. We actually started 10 years ago with an interface of Galaxy, if anybody knows that, the Galaxy portal. We combined those two things together, and that's what we went to market with, and that was in 2016. So as that's evolved, in 2019, 2020, we started connecting in these hyperscale cloud environments, and our goal was to make the connection to these environments as uniform as we could to batch scheduler systems that a lot of the people that were using our platform were used to. And this was kind of an inflection point in cloud. That was kind of one of the first times we were seeing the performance of these hyperscale clouds start to actually be comparable to like the on-prem Cray systems that we were used to running on. And you can take a code, and maybe it was a generation old system, so maybe not like the latest and greatest, but you can optimize the hyperscale infrastructure. And Matt and Steve helped a lot with this to get it to run and benchmark codes, to be somewhat close to performance or meeting or exceeding performance of the on-prem supercomputing systems. And that was kind of an inflection point when in our company, I'd say, when our customers saying, hey, maybe cloud is an option. Yes, it's much more expensive, but we can start moving some things into it. And that's when we really kind of focused on, us delivering software to enable hybrid computing, which means, a mix of public and private or on-prem and public clouds. We're seeing today a lot of those same HPC infrastructure needs from like a tooling perspective manifest with AI systems as well. The scheduler is maybe different, and we see people rolling in GPU systems into their batch schedulers, into their virtualized infrastructure, people deploying unallocated Kubernetes systems, and it's just for us another interface to work in. The last presentation, the quantum company, when they talked about how do we what's the UI to deliver the notebooks they interact with? I'm going to be reaching out to them and say, hey, we have a UI that can kind of do that, because these type of systems slide in, and I think of us kind of as like the plumbing that helps connect them, and I'm going to talk about that. So that's kind of where we sit. We're this piece of software, and I say software because we don't get involved in consumption. We're not reselling any of the clouds. We're just a piece of software that you connect these different types of infrastructure in, and we spent years and always updating really the plumbing connections to a interface to kind of collapse down these different interfaces into one. So we support Slurm, PBS, LSF, batch scheduler interfaces. We're doing a deployment with OpenStack. I was literally out in their office yesterday. 2 data centers with OpenStack. We'll talk about some use cases, different virtualized environments. We support AWS, Azure, and Google from a provisioning perspective, and we're working on bringing on Oracle and then a few other hyperscale clouds. And then GPU as a service providers are typically provisioning Kubernetes clusters and then making them available. We have a Kubernetes provider coming out in a few weeks that will be able to handle that. So that's kind of our role. We collapse these things down, and then once they're collapsed down, we have a web interface, a REST API, and a CLI to be able to interact with all these things in a uniform way. So the end users, which is typically researchers and scientists and the same type of user base that you all are very familiar with, they get into an environment where they don't have to learn the intricacies between Amazon instances and OpenStack and a Slurm scheduler cluster. They present it as one interface. So this is a little bit of screenshot of what the platform looks like. You can see in this account, it has a whole wide variety of computing types in it, on-prem, hyperscale clouds. It's kind of small, and I'll go back to it. We allow, and we're going to talk more about this, but we allow when someone gets into here, they can access these systems with one click to SSH in. So people that still want to be able to SSH into these things, we absolutely enable that and encourage it. For end users that don't want to do that, we have simple ways to deploy Jupyter notebooks and VS Code and the interactive session apps in a similar way as kind of Open On Demand does. And then some of the things I'll talk about and some of the use cases actually now running more advanced full DAG workflows as well. And this is where the power of a single interface comes in, where you can really enable hybrid workflows, where certain tasks maybe want to run on some on-prem system, and then maybe you wait a certain amount of time, and if you don't have capacity, it can automatically burst out to a cloud, and it starts to facilitate workloads like that. This is a typical deployment shape, and we're actually doing this one right now. We were out in their office, very large organization. They have 2 data centers across the country. They use AWS specifically. They're installing a global namespace file system provider. This one is Hammerspace, is on the page here. We work with lots of different storage, and that's kind of a whole breakout story in itself. In this case, they deployed our control plane, our software, in their primary East Coast data center. They connected it to their Amazon accounts. They connected it to their OpenStack cluster running on the West Coast. And the users are going in over a VPN and just accessing all these different resources from the one place. So this is kind of one example, and we're going to talk through some other deployment topologies.
So real quick.
Yeah.
You're talking about sharing this global namespace for storage, and you're sort of agnostic in which services you can support.
That's exactly right. Yes, we're the Switzerland for storage. We can integrate with a lot. We're actually resellers of a few of them, and kind of work very closely. Hammerspace is one we see more and more often. We work with Vast a little bit, a lot of the more typical file systems as well. So we're kind of agnostic.
And if there's not a global namespace,
then there is and I think I have some diagrams in here. We have recommended pathways to move things up and down. Yep, and a lot of it relates to staging up to object storage. Like when you're moving to a cloud, stage to object storage, we have things that make that kind of easy. Some organizations have like Globus, and we put Globus connects in the cloud environments, and it just appears as another endpoint. Stage to object store, pull down onto the high performance file system on the clusters, and then you can go back out when you want. So yeah, there's different pathways there. We've been seeing a lot of the global namespace kind of concept working its way into modern deployments now too. So here's this is a little video I took of like a live demo where here's the apps. I have an Amazon cluster running. This one's running Stable Diffusion on a GPU cluster on Amazon. And you can just see Stable Diffusion is kind of built into this workflow. I type my prompt in, hit execute. Our system, the person that created this workflow, took care of writing all the wrapper scripts and things. It submits it to the scheduler. This is a Slurm scheduler. And now it's actually training Stable Diffusion. This is every user gets their own little editor. They can see all the remote files in one place and access them and edit them, drag and drop download. It's showing me the training job, I believe, is what it should be showing. It's actually installing a lot of dependencies automatically. This isn't the most visual thing. It showed the training and then you get your Stable Diffusion output. So this was an example of showing a more complex workload, Stable Diffusion, running on, in this case, an AWS cluster. It's a little example of the user experience. So for those familiar with Open On Demand, are people familiar with that? I saw a few head nods, yes, several, most people in the room. So we have been asked a lot, how do we compare to that? Because Open On Demand's free and open source. I don't want to say free, it's open source. It requires managing the system and deploying it. You know, we sell licenses of our software. So everybody asks, well, how are you different? And when I get to the use cases, we'll talk about organizations that we worked with that have been evaluating Open On Demand, in some cases for years. And these are usually multi-site environments. They have, you know, multiple clusters across the country. You know, how are you different and what's the advantage? Why would I pay for something when I can get it for free? So I want to just show a little bit on that. So we've demonstrated that we have feature parity to Open On Demand. Anything you can do on a single site Open On Demand deployment, we can do in our platform, and I'll enumerate some of those things. And a lot of times we've been seeing Open On Demand having to be deployed per site. So you're having to go to each system and stand up Open On Demand, and it's kind of designed to run on that one system. We kind of collapsed that down from a single version of our control plane. You can actually then coordinate to multiple sites. And so that, for one customer we've worked with recently, they were looking at deploying Open On Demand in a redundant fashion on 6 or 7 of their systems. That would have been 12 to 14 servers, 2 in each system, and then having to maintain Open On Demand and kind of all that required. We were able to collapse that down into a single platform and connect all those sites to that. Additionally, we support multi-cloud out of the box, which I know Open On Demand was working, and I haven't checked their feature list lately. Maybe they made good progress there, but we do that out of the box. And the thing that we provision in the clouds looks and feels like on-prem systems. It's Slurm clusters that are elastic. So when you submit jobs into the scheduler, we almost spin up compute nodes then. And then when the job is done, we spin them down. So when you go to Amazon or Azure or Google or any of the clouds, you can do a lot of things in it. We're kind of assembling, I like to say we kind of assemble the car right out of the box. You click a button, you get an assembled car, which in our case is a Slurm cluster that usually looks and feels like the on-prem systems. We integrate with a lot of workflow fabrics, and I see I have a typo there, workflow frames. I should say frameworks. For things like more advanced DAG execution and, you know, full hybrid across the different resources. In our cloud environment, I'm going to talk about, but we have pretty sophisticated allocation management and enforcement of cloud spend. We'll talk about that. And then we support our deployments. So we sell licenses of our software, but we also support our deployments, in some cases, very hands-on, which is a difference as well. The deployment model for us is flexible. We have a SaaS version of our platform that you can connect your own accounts to, cloud accounts and your on-prem systems. If it can reach, it's from a single IP. If it can reach an on-prem site, we can connect to it. We sometimes deploy a platform for customers in their cloud boundary and connect to their own accounts and their on-prem systems. Or you can take the whole thing and move it inside of an on-prem boundary. We're kind of all over the map on deployments. It's a portable piece of software. This is the architecture. I probably don't need to go too much into it, but when we do a deployment, it's all container-based. We have a Kubernetes version and a VM-based or a bare metal node version. And we really just run a bunch of containers and some clusters, and every user gets a dedicated workspace. And then all the connections to the remote resources takes place from that user environment. So it's very isolated that way. These are some of the features that we actually, last year, for one of our larger customers, which is the NOAA R&D organization. They were the ones I'll talk about that was evaluating open on demand in 6 or 7 of their sites. They had an acceptance procedure where they had to compare these things directly to their open on demand proof of concept they've been trying to work in for about a year and a half. And we show that all these things you can check off and do in our platform while bringing in multi-cloud in a controlled way. So things like, everything open on demand can do, which is, graphical management of the systems, it's launching remote sessions, single sign-on authentication, et cetera. Remote file system mounting and editing, all that good stuff. So I want to talk about the cloud now. So we work in on-prem environments. Some of our customers only use us as an interface on top of their on-prem systems, batch or virtualized or whatever that Kubernetes, whatever that may be. A lot of organizations use us when they are starting to evaluate moving to the cloud, or maybe they're pretty far along in the cloud journey, and they want help usually tighten up the boundaries, or maybe they're an AWS shop today and they want to start supporting multiple clouds. That starts to become really difficult, and we'll talk about why. And it kind of relates to these things right here. So we make cloud HPC look and feel just like another site. The things that we're provisioning in the clouds, we try to make them match as much as possible a typical on-prem computing, supercomputing system that the end user communities that we're serving are already used to seeing. And so that's one big focus. And then on the sysadmin side, we're trying to make their lives easier by offloading a lot of things that we're going to just kind of touch on right here, including roles and IAM permissions. Every cloud does it differently. And when you start wanting to put a box around what people can do inside of the cloud consoles, it becomes very difficult. We kind of offload that. We offload cost control, all the bills, and I'll talk more about this. The costs are delayed coming from the clouds. And if you're fine with project teams spending as much money as they want and then charging them at the end of the month, the current cloud model fits very well. But if you want to move to like a fixed allocation model, which is what most centers do today, the cloud is not good for that because the bills are delayed. On Azure, there's a 24-minute or 24-hour delay from when you get the bills. We have users that spin up 60,000 cores at a time, and they get that in 10 minutes. They're spending $6,000 an hour or something. And if sysadmins or allocation team says that they can only spend $10,000 and the bill doesn't come in 24 hours later, this is what started happening. People were blowing past these allocation budgets. So we had to actually create a system to enforce costs at a 3-minute resolution, and I'll talk about that. And then there's some other things too. So onboarding and access is a big thing. Most organizations that use a platform like ours don't need to give the end users direct access into the cloud consoles. And if anybody's been in one of the cloud consoles, Amazon, Google, Azure, Oracle, whatever, there's about 1 million options of things you can provision. And trying to constrain that down for just the things that you want your end users to be able to do is very challenging. It becomes exponentially more so when you're working with multiple clouds because they all do it differently. So in our system, the sysadmins that are managing the cloud environments upload a credential that has certain roles, and then we use that credential to issue out all the transactions on behalf of the users. So they don't have to get into the console at all. They come into one interface, and we're offloading all the role and IAM responsibility from the sysadmins, which is if anybody's done this before, it's a lot of work doing that. All the transactions to the cloud providers, we use short-term tokens. We do deployments of this platform in a lot of different security compliance environments, our highest being FedRAMP High IL5 for DoD. So as part of that, we've had to bake in a lot of security that you kind of get out of the box with it. We have a user hierarchy that actually maps very well to on-prem allocation systems and project structures. So groups, we organize it in the form of organizations, and you can have a lot of different organizations on a dedicated platform. Each organization has groups, which are kind of mapped to the traditional computing center project sense. The groups hold the allocation, and users are put in the groups. And so they all get kind of a shared budget for their spend, and you can see the visibility of what's going on across the people in that group. Let's see. So this is on the cost control. Again, because of that delay build problem that makes it almost impossible to enforce fixed costs on the cloud. Yes, Dan.
Sorry. So there's dollar cost for commercial providers. But often for open research, we're dealing with allocations and allocation systems where time on a remote system might be done in allocations. Can it deal with that as well?
Yeah, so the actual, and I don't have a picture of it here, and I could even pop it up. The screen where you put in allocations for each group is unitless. And a lot of times when that group can run on a cloud provider, the unit is dollars. But if you if you're plugging in core hours or some other unit, it can handle that in the same way. And we've done that recently with an OpenStack deployment. They wanted to see usage metrics instead of cost because they didn't want to apply cost. And then they told us they did want to apply costs to their OpenStack resources. And we give them the ability to actually put a dollar value on their OpenStack VM shapes, and they can see the cost that way too. So yeah, it is flexible to support different units. So anyways, yeah, it maps to allocations. The group holds it. Any user in the group can open up their cost interface, choose the group they're in, and get a 3-minute resolution picture of what they're spending at any time. And this updates kind of in real time as you watch it. If you're starting to exceed, if your project has an allocation, like a cloud allocation or whatever it may be, whatever the unit, and it starts to exceed some thresholds that you can set in the platform, we have different behaviors you can apply, like send an email out to everybody in the group, send it to the sysadmins or the PIs. If it gets to another level, we have a freeze state where it will actually not allow any provisioning of new resources, but it won't stop anything. And then we have a shutdown state that will actually kill all the resources, which, is kind of the last, if you're 95%, you're spending real money, we're going to shut stuff down. Okay, that's how that works. When you provision resources or connect to resources on like existing batch scheduler clusters, this is a little bit different on existing clusters. You can kind of point it to login nodes, and what happens is we run a little agent on the login node as in user space, and then we are laying down a tunnel and we kind of handle all the connections that way. So it's a very lightweight connection to existing batch scheduler systems. In VM-based, virtual systems like the hyperscale clouds and OpenStack, you actually go through and shape the cluster that you want. So you can choose your controller login node shape, the images, you can choose how many partitions you want. We're running Slurm in these cases, and fill out a form. And this is uniform across all the clouds, and you get a cost estimate in real time on the minimum and maximum cost. And then you can just go start it. Once you create this definition, everything is then automatable with a REST API and CLI, and then people start doing interesting things like automating pipelines that are starting these elastic clusters, running jobs, shutting them down, integrating them into CI/CD pipelines. So people start doing interesting things with them. Yeah, again, this is a little bigger shot of the interface, and here at the workflow level, when you want to, we have very simple workflows like, hey, give me a Jupyter notebook or VS Code or any of the interactive, give me MATLAB running, RStudio, whatever. And then other ones are more complex, like maybe doing something like try to run it on Google, my Google cluster. If I can't get the capacity within 10 minutes, go and run it on a different cloud. And that gets baked in at the workflow level up here. And that's kind of a common pattern, actually. Let's see, we already talked about some of that stuff. Moving on. So security wise, there we go. We, like I said, we have deployed the system in many different compliance environments. And most of the time, we don't own the boundary, but we do maintain a SaaS version that anybody can get onto the, you contact us, we can get you on in like 5 minutes and create an account. And, you can plug in your cloud credentials and get up and running and try it out. And that's kind of our starter area where people test it. We do have production customers in there as well that aren't as concerned about the actual control plane boundary where that lives. But a lot of times in larger deployments, we take the software, we move it into their dedicated cloud environment. We have systems running in AWS, Google, Azure. Kind of doesn't matter. A lot of the times we'll deploy in Kubernetes there. And then we also do on-prem deployments, like I said. From a security compliance perspective, sometimes we own the boundary and we're responsible for the compliance, like in this DoD platform that we're standing up for the MOD program. The MOD program runs DoD's shared enterprise computing systems. They had us own the IL5 FedRAMP high boundary, which means that we have to go through the 400 plus controls and ensure that we are in compliance to all of those controls. And then we go get audited and then it gets reviewed. So that one we're doing actually right now, and we're about at the finish line of that. It's taken like 2 years to do that. Another example here, Raytheon, we work with on an engagement. They wanted to operate the FedRAMP low environment, and they're responsible, but it's a shared responsibility model. So for some things we're responsible for, like in our software, like password rotation and all that, but then they own a lot of the surrounding compliance. So we're familiar with a lot of these type of things. We're looking at rolling this mod program system out to a formal FedRAMP high platform that could be shared as well for government. This is a summary of what we just went through, so I'm not going to touch on it again, but this is kind of the value we bring when you're trying to operationalize these type of programs. I'm going to talk about some of the case studies now. I see I'm at 30 minutes, so I'll talk for 15 more minutes and see where we go. All right.
Could we pause just for a moment and see if there's any questions before you get to the case study?
That's a great idea. Yeah. Questions, comments. That was a lot of info. Matt and Steve can answer anything as well. They're working with a lot of our customers on the front lines, supporting them on this stuff. So feel free to interrupt me.
So I would ask do you have any uptake from any of the other educational organization or institutes?
We have one educational deployment at the moment.
Okay.
And that's it. It's Albert Einstein College of Medicine.
Okay.
They've been our customer for 4 years, 3 or 4 years now. So we're in the 4th year. And we operate 2 platforms for them. They have basically like a campus cluster environment that you access over VPN. And it's on one large Slurm cluster with a lot of storage. And they've been migrating that along. They just had us move that deployment into Kubernetes. They brought in OpenShift. So we moved our platform into that. And then they stood up it's not HIPAA compliant, but it's for clinical research data that's fully isolated. And they had us stand up a duplicate platform for that environment. And mostly that's radiology researchers coming in and doing clinical research stuff on that. So that's probably, a few hundred users in that environment. And that's our, I guess we're a little new to the educational sector, but we've been doing that for quite a while. And a lot of it, honestly, is because their open on demand has a lot of uptake in the academic communities. And, we're going in now trying to say, well, yeah, we have a cost, but there's a lot of benefit. So it's
and it'd be fair to say for NCSA, we use Open On Demand as a graphic interface, a very limited graphic interface to most of our systems.
Mm-hmm.
Often it's not used as a traditional workflow organizational tool.
Yeah.
It's more of a way to provide users.
It's a portal. It's a conventional portal for your
first
session.
Login, file system checking, maybe notebooks. But again, not really orchestrating data flow.
Right, exactly. And we kind of handle the argument there is, we do those capabilities, but then a lot more was what we end up having to describe. So I'll talk through a few, any other questions before I go into some just case studies and things we got in progress? No, okay. I'll talk about a few of them. I actually I forgot to add in the slides for Albert Einstein College of Medicine. I was going to show that, but I kind of talk through a little bit. I'll start with the NOAA R&D organization. So this is the weather agency's R&D community, and it's the people that are building the next generation weather codes and working on teams, maybe trying to scale into the operational systems. And it's a very wide range of things they're doing. It's all focused on R&D though. They had a mandate. I think we're in our fifth year, Matt, fourth year with this, maybe fourth year. So they've been a customer about 4 years now. They got a mandate from kind of the top level that they wanted to start adopting cloud in a serious way in an enterprise shared fashion, which I think from the government organizations that we talked to, it was a rare thing having someone say that at the leadership level. So they put out a competitive solicitation for a software company to come in and help them run their multi-cloud environment. And it started as multi-cloud. The first year that this started, which was 2021, I kind of know, something like that. They only wanted AWS, Azure, Google. They wanted uniform provisioning across all of them, and they wanted someone to help them apply the allocations. They were going to buy a bunch of cloud spend, allocate it to their user base, and they needed someone to keep track of that. And we were a really good fit for that. Some of our competitors, they charge on consumption. So they're taking fees on like your Amazon spend, and they didn't like that. So we said, hey, we're user-based, and all you got to do is connect these things in. And we won that, and it grew now. It started with 100 users and about $1 million in cloud spend that they allocated across AWS, Azure, Google. That's grown now to be rolled out to their entire user base, which is about 1,200 users, our engineers and scientists. Last year, they had us connect to their on-prem systems to be a true hybrid interface, gateway. And now they're buying about $10 million of cloud spend and allocating it across the 3 clouds through our platform. And on the platform, if I were to open up, there's probably 60 or 70, maybe, Matt would know more, project teams that have dollars allocated. Some of the projects are really big. Like I think even one project has like $2 million a year because they're running hurricane forecasts, and they come in, and Matt presents this in different places. But they come in and run it on one of the clouds. I think last year they selected Azure. So they had a 3-month allocation, $2 million on Azure. During hurricane season, they ran this thing every single day. Project's over. This year, they're moving to AWS, and they're just lifting it and moving it over. So it becomes quite easy to do that. They had very strict performance requirements. We had to benchmark their codes to their on-prem Cray machines and make sure they are at least can meet or exceed it, which was difficult to do on some of these clouds. It's getting easier. Steve just did WCOS2, their operational supercomputing system. We had to do benchmarking to compare to that one, which is a fairly new system. I think a year or two old. Anyways, so that's kind of what that's about. We kind of sit in the middle. They have a dedicated domain name they log into. It's actually open to the publicly accessible, but it taps into their corporate single sign-on. They use Red Hat SSO. And then once the users are in, they can connect to the cloud systems they have access to. And then if they have on-prem allocations, and they do core hour scratch disk allocations, if they have access to that, they've given this platform basically the ability to act as a bastion node. So it's checking out SSH certs. They actually use X509 certs on behalf of the user, and they can SSH seamlessly to any of the systems without having to do a second authentication. So that was what we did last year with them. And we're doing the same thing with the DoD now. And I think I'm going to talk about that. This is the shape of things we provision. This will be quick, but our platform sits over there. We call the platform Activate, by the way. And then HSP means high security platform. So I think I showed this in a DoD one. High secure is our FedRAMP High IL5 environment. The user comes in, they have their own kind of dedicated user workspace. They're able to provision these cloud clusters where they get a controller node for the life of the cluster session. And when I say cluster session, is you can start and stop these things kind of on demand. It takes about 3 minutes to get a new one. The compute nodes scale up when jobs are submitted in the scheduler, and then they go away after a dwell time that you can set. There's a wide variety of storage types that can be added to these things flexibly. You can mix and match, NFS mountable storage, high performance Lustre file systems. We use to manage Lustre services or provision our own Lustre clusters depending on the cloud. You can provision object storage. What am I missing? Disks, attach them, snapshot them, a wide variety of things. And yeah, we do that uniformly across these environments. Oracle, we have coming soon. And then on-prem, again, it's a very lightweight connection to an existing batch scheduler cluster. If we have access to the login node, or we can get a cert out that gives us access, we run a little worker agent. It's a lightweight agent, lays down an SSH, everything's over SSH, lays down an SSH tunnel. And we use that to transact to the system and basically abstract the scheduler calls away. That's what's happening there.
Is the worker limited to like the login node for an on-prem cluster?
It is not, no. And in fact, when you submit a job to, through our platform to the system, and it's, let's say, starting a Slurm job, we usually run the worker on the compute nodes as well, because that's what shows them connected to the platform. And then you can do things like get easy access and visibility into it. We have some observability stats that push up, not to the level of like Prometheus or Grafana, but like once a minute, we push up general stats. You can see Slurm activity uniformly across all the systems, things like that. We use the worker for that.
So the worker doesn't exist as like a continual service running on like a login node. It's only there when you log in and start.
As the user space. Yep, very lightweight thing that gets sent over and run. And that's, you can even run it on your laptop or something and it would connect in the system. That's a bigger screen at the dashboard. This was looks like my account. I had $13,000 allocation on Google and we spent most of it. And Dave Ingram was running most of the jobs on that. That's what that shows. So you're able to see the visibility across the rest of the users in your project. So another case I wanted to just show, like and Dan mentioned this, we do the simple interactive sessions, like give me a Jupyter notebook or remote desktop or whatever, VS Code. But our workflow framework was actually modeled after GitHub Actions. And so you can write a YAML file and it creates a form, an input form that you can connect to multiple tasks within one workflow, just like GitHub Actions work. We modeled it right on it. You can see a simple DAG. And then when people want to run maybe more hybrid workloads or more complex workflows, they may want to run something like Parcel. And we do a lot of integration with Parcel as well, just kind of that's kind of where our roots were from. So in this example, here's a Jupyter notebook that's a Parcel workflow, and it submits things using this, I think the Slurm provider probably, to these clusters. And you can track the full DAG and add tasks into it, and it kind of is a much more complex workflow execution fabric. This is our high security platform, is for the HPC modernization program. They run 12 or so unclassified and classified systems for cross branch in the DoD. They had us deploy our platform in AWS, is where the control plane sits, and then connect it to NipperNet. So it's actually hosted at hsp.mil, highsecurityplatform.mil, and they're the first customer of it. So they have a domain name, hpcmp.hsp.mil. And I think we're going to get a better name for that because it's a lot of acronyms. But it connects to, so similarly, they have a portal right now that they've built really over a decade. They have a version of it running at each separate site that they have across the country. So they're maintaining like 5 or 6 different portals, and they're not very flexible. It's basically what Open On Demand does, but they created it before that was even an option. And they actually have people experimenting with Open On Demand as an alternative too. We connect to all those systems, same single sign-on SSH authentication, right? When you log in, we get the cert out and you're able to SSH to their on-prem systems. They have a lot of PBS, so all the same workflows work uniformly to the PBS clusters they run. And then we're bringing in the IL5, which is ITAR compliant cloud resources, which was a big lift. And we have AWS supported now, Azure's coming next, and then Google. And in this one, these groups are actually, they're paying us to be part of the platform, which is interesting. They're helping us out by funding us to fold in because they don't want to be left behind or something. I don't know. Here's an example of a group that was doing synthetic aperture radar workflows. So a form was built. This is a parcel workflow. You hit execute. Once you hit execute, I think you get the parcel visualizer pops up, shows the state of each task in the workflow, and I'll kind of skip through this. This was a machine learning training, so it's training image detectors based on SAR imagery, radar imagery. And at the end of it, the workflow finishes, you're actually able to navigate to the remote system. This is, sitting in Vicksburg, I guess, this cluster, and see the resulting system images that were predicted and whatever. So that's kind of like I'm actually viewing into a remote system. Let's see, we're at 40 minutes. There's a few notes on the in-progress deployments. On Monday, we were out West Coast talking to presenting the results of a deployment we just did for a large EDA company. They were the one that is, I mentioned that diagram with 2 data centers before. We're doing something similar like that. They're a NetApp shop. So we allow provisioning of NetApp resources or volumes through our platform. And then you can attach the NetApp volumes to the OpenStack clusters that we're provisioning for them. They wanted Slurm clusters on OpenStack, which is, I never thought I'd be saying that, but that's what we're doing for them. And they wanted that because they have a bunch of batch scheduler systems already, and their end users are used to that. So that's the shape that we did there.
We have one of those.
You have an OpenStack, Slurm on OpenStack?
Mm-hmm.
Ah, there you go.
It's pretty static,
Okay.
but it does allow for flexibility for the cluster to expand or shrink on a rational time frame basis, but it provides the users that are familiar with the batch system a familiarity.
Got it. Yeah. So that's exactly, we did the same elastic shape of cluster that we do in all the other clouds, where you get a persistent login node that is owned by the user, or they're actually doing it owned by the project lead. And then the project lead is sharing the cluster with their end user teams. And then the compute nodes are all elastic, like on AWS. So when you go into this environment, you really can't see the difference between AWS and OpenStack at all. They look exact and feel exactly the same. So when you submit jobs into Slurm, it goes out, hits the OpenStack API, spins up nodes, runs the job, and then shuts them down when they're done, frees them up for the rest of the users. They have a connection to the FSx ONTAP, which we're adding right now too. They wanted to use that as a way to get data flex cache into the cloud as well. So that's happening. They're having us move this one to a separate environment, a new OpenStack environment, and then they actually want to take a version of our control plane and move it actually in AWS as well. So there's a lot of stuff going on. They're moving this software around because there's accessibility issues getting directly into their OpenStack. So that's what's happening with that. We're doing a deployment for a AI sandbox environment, they're calling it, where it's a defense contractor. They're in Honolulu. They are purchasing an AI sandbox system. So it's kind of a GPU-based and CPU system. They want to run Slurm and/or Kubernetes on it, and they haven't really decided, and they may want to do both. And so they're going to be using our existing cloud-based high-security platform environment. We'll be connecting that to the on-prem system when that's running. They're using we're not a cluster manager, by the way. We rely on a cluster manager to be there. I think they're using Bright on this one because they're buying mostly NVIDIA or Base Command now. But they also talked about maybe using something like Rancher or something, and they don't want to do OpenStack, which was another option that we were saying. So we build on top of the cluster manager.
So
yes, Dan.
Real quick, the Activate control plane, how heavy of a load does that take if you had one located on premise? Is that, you said Kubernetes cluster, so I'm assuming multiple nodes?
We support 2 deployment models. We have a Kubernetes version, so it's all containerized.
Sure.
We have a recommended architecture when we deploy, which is usually spread on 3 VMs maybe. We like to separate out the databases and the user workspaces. You could collapse it all down into one and just it's running maybe 10 containers for the entire service on one VM.
And you could run on real hardware.
We've done bare metal with Podman and whatever, yes. Yep. And that's what Albert Einstein College of Medicine, they are all bare metal. They gave us bare metal nodes and they used Podman. We did the deployment with that. So it can be pretty lightweight, but then when there's a larger user base, we do recommend going to something like Kubernetes because every user gets their own dedicated container environment, which gets served up with when they log in. And that's the thing that grows and really shrinks as the user base changes. So that's where Kubernetes has an advantage. When we're doing like a VM or bare metal deployment, that user node you may need to grow it as the user grows because it has to support a bunch of containers on it. That's all I got. And that was 45 minutes, almost exactly. So any questions or
Questions from anybody online?
comments?
Questions from the audience here?
How do you guys differentiate yourselves from Rescale? Is that a fair question?
Absolutely fair. We've been competing with them for 10 years. I see them, so there's similarities from a mission perspective, cloud HPC. First of all, they're really a cloud broker. That's what they're doing. They are reselling cloud cycles and they don't tell you where they're getting them from. And I'm not bashing their model or anything, but like you go on and you get a Onyx flavor, it's actually running on a VM on Azure and they're charging a markup 20-30% often. And I'm not bashing the model, but so they're really a cloud broker. We're a software provider. We sell our software and what I like to say is like we enable the organization to turn their own cloud accounts into what Rescale does. Like you can take our software, plug your accounts in and provision these clusters right out of the box and do, what Rescale is kind of abstracting away behind their interface. They're a lot more focused on digital engineering too. I mean, they did a really great job of going out to the software ISVs, especially in digital engineering and manufacturing and like working with them for on-demand licensing and things like that. We've kind of stayed away from that space specifically because the software costs are the things that start to become really the ANSYS costs and all that become really expensive. And we focused more on the ecosystems that people bring their own software tools, things like that. We sell named seats. So, and they're usually annual, but we can do monthly as well, where they're basically active slots for a named user, and you are able to turn those off and on as you want to an extent. Just the people. Yep, that's exactly right. Yep. We made the decision to move that probably 5 years ago, and we used to kind of mark up cloud cycles, but we moved to just a named user model. And then we do support as well. So we have 3 support tiers and they're kind of bundled together. And a lot of times, companies we work with, they start small and just try it out and they'll start, I think we do minimum 5 seats and then people grow, you can grow into it when people like it. That's the idea. Yeah. Good question though. It's interesting. We've been Rescale has been our big competitor for many years. Still is. We compete with them on stuff all the time. We've been moving into a different competitive sphere with like Run AI and like the software Kubernetes control planes. And people are looking at us to like, how do we compare with those type of tools, which is doing kind of allocation enforcement for Kubernetes resources. So that's been a different world that we've been starting to toe into. That was a good question. Questions or comments?
Thanks, man. Very good.
Sure.
Yeah, it's very good, helpful for us to understand it. There might be a place to present this to not the service provider side, because often we wouldn't make this decision,
See.
right? We're one of the people providing cycles, right?
Mhm.
And so maybe our engagement directorate, where we have the individual projects for NCSA, or possibly other campus departments that have to do things.
Yep.
They would be the ones who are deciding, am I going to use the cloud? Am I going to use on-prem?
And I have some budget and, oh, they can plug it in here or something.
And so those might be the ones, they would be the
Got it.
ones who make the decision of using this.
I see. Okay.
This is helpful for us so we can understand what the options are.
Yep.
And maybe bring it up to people, right? When they say,
Great.
hey, I want to have a blog.
Perfect. Okay. Yeah, that's great. Very, very helpful context. Yeah, appreciate everybody's time. I'm gonna turn this off.
All right. Well, thank you, everybody. Thank HP, thank AMD, thank IQM, thanks Parallelworks. Appreciate everybody coming to the workshop.